Warm gas. Today we'll be studying about warm gas. Okay, so we'll be covering in this as a design procedure of warm gas and a few problems based on warm gas. So we'll be using data handbook 4th edition Balbi by Balbi. So this is just a basic what is actually warm gas are meant for. This is just a geometrical representation of worm wheel and a worm. Okay, so you can see this is a worm and this is a worm wheel or a worm gear. This is one of the tooth section of a gear, so which is meeting with the worm teeth. Okay, so there is one additional parameter which come into existence with respect to worm gears, that is a lead angle. So lead means what? Ahead, just a step ahead. So what makes you to give a lead angle? Okay, so you can see here. So this is a worm gas, the representation you can see. So for one particular rotation, okay, so for one particular rotation of the worm, so what is your lead? Okay, just a movement for further. So what is that movement? Okay, we call it as lead, which is L. Okay, that nothing but the distance which is moved. Okay, so the representation of the diameters, helix angles, pitch cylinders. Okay, so we'll be studying in a different problems. Okay, this is just for your understanding. So this is a design procedure for worm gas. So as different gas, the similar first step is to have a material section. Okay, select suitable material. Okay, you can go with the same section of materials which you have solved with respect to worm gas. Previously we solved with respect to spur gas, helical gas. The material for the worm is hardened steel. Generally we consider it as okay, and that of the worm wheel is of phosphor bonds. Next one is design is based on worm wheel. So by default, unlike previous gears, that is spur gas and helical gas, so where we define the weaker part by using the strength factor. But in worm gas, we by default fix it as a weaker part, that is worm wheel. So what is the reason behind this? The worm gear is assumed to be weaker than the worm since it is subjected to sliding action. Okay, as you can see in the previous picture where you can see the sliding action of the worm wheel, so thereby resulting in overheating and leading to failure at a higher RPMs. Okay, so this is the main reason why we choose the worm wheel as a weaker part. Okay, so next step, as usual, in helical gas and spur gas, how do you decide the starting step to find the modules based on diameters? Okay, so first here in worm gas, we need to find the diameters. So to find the diameters, which are of two types. Okay, so first step is when the center distance is known. I repeat, when the center distance is known. Center distance between what? Worm and the worm wheel. If the center distance is known, so you can find the pitch diameter of the worm as this formula. That is you'll be getting from page number 223. Okay. Similar to that, if pitch diameter of the worm gear, so this is the formula. Okay. A is nothing but the center distance. I repeat, A is nothing but the center distance, which is average of two diameters. Okay, so if you know d1 here, if you substitute d and you know a, I told you center distance is known. Similarly, you can get the value of diameter of worm gear. Okay, so this is clear. Now if center distance is unknown, I repeat, if center distance is unknown, so we use a first step to find the a. I repeat, we need to find the A. So where power will be given, okay, the velocity ratio will be given. So from there you need to find the value of A. And then again the similar procedure. Okay, now so this is done to find the diameters. Second step is to find the module. Okay, so this is the step which we use to find the module. That is from page number 223. Okay, so here to find the unknown values from this formula. So we generally considered worm gear as a weaker section. Okay, we consider worm gears as a weaker section. Hence, we take it as same value. Okay, now velocity factor. So here the velocity factor is decided and it is constant, which will be taking as this. If you know the value of V, so substitute you will be getting CV. Okay. Now minimum face width. So here face width will be taking from this formula when A is known. Okay. So this formula is from 227 page number. Okay. Next is FT. So the same procedure 2 times of mt divided by d2. Okay. So here the torque momentum is taken as mt into KL, where KL is the load factor which you have to substitute. In general, if he has not given the load factor, you can take it as 1. Or usually you can take it from page number 248. Okay. So next, how to find the value of mt? You know the power formula 2 pi n2 into mt. Okay, guys. So be clear in this step. Okay, I repeat, here we are using small n. So what does that mean? It is rotations per second, RPS. Okay. Similarly, here also in power formula we are taking small n. So what does that mean? RPM you have to substitute in seconds. Okay. This is very much important step. Clear? Next. So to find the value of Z1 alpha and Y, I repeat, to find the value of Z1 alpha and Y. Okay. So we will get the value of I factor. If you check these tables for I dash, what is Z1? Okay. For gamma is alpha. Similarly for alpha, what is Y? We will be getting for corresponding value in this table. Lead angle. Check in as I told you how to find the lead angle. All the formulas are lined up in the which will be taken from page number 221. You can take gamma represents the lead angle. Okay. Next one. D. To find the dynamic tooth load. As usual, you can find the dynamic tooth load by using this. Is done. So we shall move to next step. Page number. Okay. So there the dynamic tooth load is given. Okay. Now next step is to find the wear load. Similarly, we take D2. Why? Because your worm wheel is weaker. Okay. So this is the formula which will be taken from 227, where K is the load stress factor. Okay. K is the load stress factor which you will be getting from page number 12. Table number 12.30. Okay. Next one. So you can take it from page number 246 for this. Okay, 12.30. So the wear load must be always greater than the dynamic tooth load, that is dynamic strength of gears. So hence we can define it as a safe against wear. Next one, to find the efficiency. Okay, to find the efficiency we will be having different formulas in data handbook, where the consolidated efficiencies of worm gear is taken. Now, so there are two types of efficiencies. Okay, the efficiency belongs to when worm drives the worm wheel. Okay, so it means you are giving power to the worm and it drives the worm wheel. Okay, nothing but worm gear. So this is the formula which you will be getting from data handbook, page number 225. Not in general that you can use this formula itself. There is another formula which you can see, B, 12.57 B. Okay, so there when worm drives the worm gears. Okay, when worm gear drives the worm. So just take it as 12.57b formula. Okay, you can take any of this, but depends on the question what they are asking. And how to find the unknowns in this formula? The first thing is theta. So tan theta is tan alpha into cos gamma. So this formula will be getting from page number 224. Okay, so that is 12.56d. Okay, 224, page number 12.56d. From here you will get the value of theta. Now there is one more unknown, that is rubbing velocity, that is coefficient of friction. Okay, which you will be getting from rubbing velocity Vr. If you go to page number 226, okay, so there you will get the coefficient of friction. This is the formula. Okay, so before that he needs rubbing velocity here. Okay, so to find the rubbing velocity, this is the formula, okay, which will be substituting the values of diameters and RPMs, okay, RPS, okay. If you substitute it, you will getting the rubbing velocity. If you substitute the rubbing velocity, you will get the value of mu, okay. You know the rubbing velocity means the engagement of two gears, that is worm and the worm wheel, okay. Since the number of teeth will be in a reaction, it will subjected to the rubbing velocity, okay. Next one is heat generated. Okay, so there will be a lot of heat which will be generating due to higher RPMs and larger gear reduction ratios which are under consideration. Okay, due to that there is a so much amount of heat which will be generated. Okay, so heat generated and heat dissipated. Okay, so heat generated depends uh, mainly on the engagement of two teeth and the gear reduction ratios. Okay, so how to calculate that? By using page number, using this formula from page number 227. Okay, so here there is unknown which is Fn, which is Fn. There are two formulas which you can use, either one of this or you can use this. You can use this formula which is available in the data handbook, that is page number 255. Okay, 12.56i. You can use this formula. Okay, next is heat dissipated. How much amount of heat dissipated is calculated using this formula, that is 12.63, page number 227. Same below that formula you can find this formula. Okay, so there is one more formula. Okay, so this is also heat to be dissipated formula. Okay, so where AWAG defines the projected area and the area of the warm gas, and T1, T2 are the gear temperatures and room temperatures. If in the question he has given in terms of areas of gear and where warm gas and temperatures of the surroundings and the gear temperatures, then you can use the heat dissipated using this formula. Okay, so both one depends on the question what he is asking. Okay, so there is one general condition. I repeat, there is one general condition. Usually your heat dissipation must be greater than the heat generated. So the center distance is known. As I told you, dissipation of heat is more than the heat generated. No need of cooling. Okay, artificial cooling of gears are needed. He is asking design a warm gear drive for a generated is more than heat dissipated. What is given? The amount of reduction which generated between the gears will be high. The pinion rotates at 600 RPM and transmits 35 artificial cooling. Okay. So this is your the very first step is to convert RPM to RPS. So let's see the basic problem, that is 600 by 60. You will get 10 RPS. Power he has given. Okay. So one of the RPM he has given, you can find the another RPM by using this velocity ratio. You will be getting N2. Okay. Now identify the weaker part. Okay. Since the material is not specified, let us assume worm and pinion. Usually you can take it as worm here. Okay. So this is just for a practicality by assuming the materials. Okay, a worm which is made up of C30 heat treated steel, and worm gear I told you should have assumed phosphor bronze as I given in the design procedure. Okay, Now, the worm gear is assumed to be weaker than the worm wheel since it is subjected to sliding as the same statement which I have written in design for your understanding. Now, the very first step to find the center distance because center distance is unknown. Okay, this is one type of problem if center distances are unknown. You can go to page number 228, there you can find this formula where power is given, the velocity ratio is given, you can find the value of A. Okay, so once you get the value of A, just substitute the value of A in the before formula, that is 223 page number. You get this formula D1, substitute the value of A. If D1 is known, simultaneously substituting the average formula, you will be getting D2. That is D1 plus D2 by 2. So here you will be getting the value of D2. Okay. Next, to find the module. As I told you, this is the formula from page number 223. Just write it down. Okay. Here, to find the value of CV, that is velocity factor. First, before that, we need to find the value of velocity. That is pi D2 N2 by. Okay. So here N2 represents RPS. I am repeatedly telling you guys RPS. Okay. You can take it n also because the formula can be converted to pi dn by 60. So that is not a big deal. But before that, if you convert it, it will be easy for you to substitute that. So next CV. Okay. Next is face width. So this is the page number 227 to find the value of face width. Just substitute the center distance A. Will be getting the value. Now next one is FT. Okay, tooth load. So this is the effective torque, where effective torque is taken as MT into KL, where KL will be assumed as 1 as a load factor. Now how to find the value of MT? You can use the power formula 2 pi NT by 60. Okay, so you can take directly N as RPS. So from this formula you can find the value of MT in Newton mm. So once you get the value of MT, substitute back here. KL you know assume and D2 is known. You can get the value of FT. Okay guys, so as I told you, if you go to page number 244, okay, so there these values are given uh, where I is greater than, you know what is the velocity ratio he has given 25. Since I is greater than 20, okay, so I is greater than 20. So if you see this table number 12.28b, for I is greater than 20, the number of threads in worm is single. Okay, okay, it is single. The action between the gear and the worm, which is made up of single thread. Okay. Next one. What happens? You can find the similar corresponding Z1 as 1 because there is one action. The single thread is made up of. Okay. Next one. For Z is equals to 1. So what is your alpha? That is your pressure angle. You can see from page, the same page. Okay. That is sorry, 243 page number. Okay, the very first thing, normal pressure angle alpha. Okay, so for a single and double threads, you can see at the top for a single and double threads for a Z1 is equals to, it is alpha 14.5, that is 14.5. Okay, corresponding to that you have to take. Now for alpha is equals to 14.5, you can come back to page number 244. Okay, that is 12.28c. For alpha is equals to 14.5, you can get the form factor y is equals to 0.1. Okay, now if you substitute all the unknown values in this in this formula to find the value of m, you will be getting 13.26. As you all know, I have to standardize the model from the table 12.2 page number 229. You will be getting 16. Okay. So next is lead angle, tan bar gamma is equals to m z1 d1. Okay, substitute the value of m z1 d1, will get the value of gamma. Next is dynamic tooth load. Okay, so dynamic tooth load, he has given the allowable static stress. Okay, so you have to take the value of gear, worm gear or worm wheel. Why? As I told you, it is a weaker part, sigma d2. Okay, b you know, y you know. Y is, this is capital Y. I repeat, this is capital Y. So capital Y is nothing but pi into small y, where small y represents your Lewis form factor. Okay, so which you found it from previous one. Then M, so you'll be getting Fs, that is dynamic strength or dynamic tooth load. Next step is to find the wear load. So Fw is equals to D2bk. So D2bk. So what is k? You can take it as 0.549. Okay. So how to take this value, k value? Okay. So you can see the gamma. Okay. You can see gamma. I repeat, how to find the value of k. So go to page number 246, that is table number over 12.30. So there your gamma value lies between 0 to 10, correct? That is 5.89 with the value which we got. Okay. If you see there, the worm is of hardened steel, correct? And gear is made up of phosphor bronze. So if you check second one, that is corresponding to that value, you will be getting the K value, that is 0.549. Okay, 0.549. So if substitute the value of K here, you will be getting the value of Fw. So check whether Fw is greater than Fs. Yes, it is greater than that. So the material will be safe against wear. The next step is to find the efficiency. So how to find the value of efficiency? See, here the worm drives the worm gear. Okay, consider it when the worm drives the worm gear. So this is the formula which you're getting from page number 225. Then how to find the value of theta? That is tan theta. That is tan alpha into cos gamma. Alpha you know, gamma you know. Okay, you will get the theta. Now how to find the value of mu? Before that we need the rubbing velocity, that is VR, pi d1 n1 by 1000 into cos gamma. Okay, so from here you will get VR. Okay, next one. Substitute VR here, you will be getting the value of mu. Okay, so if you substitute the value of mu and theta here, you will be getting the efficiency, that is 70.54%. Okay, next one is heat generated. So the same formula which we'll be using from page number 227. Okay, how to find the value of Fn? You can take this formula. Okay, that is, you can go and use this formula as I have written here clearly. From the table, from the equation, you use this formula. Okay, so this is unknown in the data handbook, which is a certain derivation. Okay, you can take it from page number 225, that is 12.56i. Okay, use that formula and find the value of Fn as I have written in the design procedure. You will get between heat generated. Now heat dissipated, we calculate using this formula, where kilowatts you need to substitute the power value, and efficiency substitute will getting heat dissipated. Now heat dissipated must be always greater than the heat generated, correct? Since your artificial cooling is not required, not necessary. Okay guys, so this completes your design problem. Okay, per warm gas. Okay, so thank you.